Flight School on the Red Planet is a production of the Fairfax Network in conjunction with the Smithsonian National Air and Space Museum Stephen F. Udvar-Hazy Center, with a generous grant from the Gertrude E. Skelly Charitable Foundation.
It's one small step for man, one giant leap for mankind. This is going to be some kind of different ride.
Hello, welcome to Flight School on the Red Planet. Our flight plan is simple. Let's explore Mars. Our classroom today is the Smithsonian National Air and Space Museum, Stephen F. Udvar-Hazy Center in Chantilly, Virginia, which is home to thousands of amazing space and aviation artifacts. We know from observations that Mars is a dynamic planet. Robotic rovers on the surface and orbiting spacecraft have revealed that Mars is the most Earth-like of any other planet in our solar system. Let's learn more about the Red Planet.
Everyone knows Mars is the red planet, but do you know why it's red? It's because the planet is rusting. Well, not really, just the rocks. Many of them are made out of iron, which oxidizes or rusts when exposed to the elements on the Martian surface. This red color was the inspiration for its name, which comes from the mythological Roman god of war. Some cool features of Mars are a huge volcano, the largest in the entire solar system. It's called Olympus Mons, and it is 3 times taller than Mount Everest. Plus, check out this canyon. Valles Marineris is the deepest canyon in the solar system. It's 4 times deeper than the Grand Canyon. And if it were on Earth, it would stretch from New England all the way to California. Along with Venus and Earth, Mars orbits in what is known as a habitable zone. This is an area around a star, like our Sun, where it's not too hot or too cold. In other words, it's a Goldilocks zone, because it's just right for water to exist on the surface. Water is a key component to life, and therefore, planets within the habitable zone are thought to be the best candidates for planets that might sustain life. Mars is on the outer edge of the habitable zone, and Venus is on the inner edge. Earth is right in the middle. So why are scientists so interested in exploring Mars?
One of the reasons to explore Mars is because it actually happens to be close, so that makes it a little bit easier. But it's a terrestrial planet, which means that its formation processes were similar to Earth. So that process of how life started on our solar system may actually be preserved on Mars, whether or not life ever got started on Mars.
Earth and Mars are similar in many ways. Earth is tilted 23.5 degrees on its axis, and Mars is tilted 25 degrees. This gives both planets the same 4 seasons. Mars even has 2 polar ice caps. Though, because of Mars's more elliptical or oval-shaped orbit, the temperatures are more extreme. In fact, if you were standing at the equator on Mars, it would be summer at your feet and winter at your head. How's that for extreme? Days on Mars are slightly longer than days on Earth, at 24 hours and 39 minutes. Some Mars scientists even set their watches to Martian time. The entire planet is only about half the size of Earth, but its entire surface area is roughly the same as the surface area of dry land on Earth. Though it may be small, it certainly captured the attention of even the earliest astronomers.
Since the dawn of time, humans have looked up at the night sky and wondered about the heavens, filled with so many bright objects in constant motion. Ancient astronomers built tools called astrolabes to better understand the movement of stars and planets. At the downtown Smithsonian National Air and Space Museum, these astrolabes are both highly detailed and precise, proving that the early astronomers understood more than you might think. In the 2nd century, Ptolemy, a Roman citizen and astronomer, developed math formulas to account for his observations. In 13 books, he catalogs the stars, lists the constellations, and attempts to explain the movement of the planets. By using an astrolabe over a period of several weeks, Ptolemy knew that the planets moved slowly among the stars from east to west. In fact, that's where we get the word planet. It means wanderer in ancient Greek. This wandering of the planets is what puzzled Ptolemy. Every 26 months, Mars appeared to move backwards. So what might account for this backwards or retrograde motion? Well, Ptolemy viewed the Earth as the center of the universe. Since you can't feel the Earth move, it must be at the center, right? Of course, we know now that this isn't true. So, to explain the motion of Mars, he made a complicated system of circles within circles. Several centuries later, an astronomer named Copernicus figured out a simpler system which placed the Sun at the center of the universe and the Earth and other planets orbiting the Sun. This new model better explained the retrograde of Mars. The planets were simply moving at different speeds. As the faster Earth caught up with and passed the slower Mars, the movement as seen from the perspective of Earth would make Mars appear to move backwards. The Mars retrograde still occurs every 26 months. In fact, as of this broadcast, it's happening right now. Using telescopes, modern astronomers are observing the same movement that puzzled the ancient astronomers. It wasn't until the invention of the telescope that man was able to get a closer look at the planets. In the 17th century, Galileo, known as the father of modern science, built a telescope and pointed it to the heavens. Based on his observations of the planets, he agreed with the Copernicus sun-centered model and challenged the still widely accepted belief that the Earth was the center. At the time, this was such a controversy that he was held on trial, sentenced to house arrest, and the publication of any future written works was forbidden. But this didn't stop the scientific discoveries from telescopes. Throughout the 17th century and even to date, technological improvements to the telescope have furthered our understanding of the planets, our solar system, and even galaxies beyond our own.
Up next, Mars has a place in our solar system. Then, Martians take over the Earth. But first, did you know that Mars has 2 moons? Meet Phobos and Deimos. These lumpy, heavily cratered moons are thought to be asteroids captured by the gravitational pull of Mars. Phobos whips around the planet 3 times a day and is spiraling inwards as it orbits. Someday, millions of years from now, the doomed moon might even crash into the surface of Mars.
Mars is the 4th planet from the Sun in our solar system. An easy way to remember the order of all the planets is to use an acrostic sentence. For instance, my very educated mother just served us noodles. Here's how it works. The first letter of each word represents the first letter of a planet in distance order from the Sun. M for Mercury, V for Venus, E for Earth, M for Mars, J for Jupiter, S for Saturn, U for Uranus, and N for Neptune. So if you remember that my very educated mother just served us noodles, then you've also just remembered the order of the planets in the solar system. An acrostic sentence is an easy way to help your memory. You'll notice that Pluto is not included in the order of the planets. It is now considered a dwarf planet and joins 4 other dwarf planets named Aries, Haumea, Makemake, and Ceres. There are potentially hundreds more orbiting objects that could be added to the list of dwarf planets. Could you imagine the acrostic sentence we'd have to make if we included all those potential dwarf planets in our system? It would be more like an acrostic paragraph.
It's hard to talk about Mars without talking about Martians. Though the idea of green, bug-eyed, and highly intelligent Martians may seem silly today, it wasn't too long ago that some people thought these popular icons of science fiction were actually science fact.
In 1877, Giovanni Schiaparelli, an Italian astronomer, used a new high-powered telescope to look at Mars as it made one of its closest passes to Earth. From these observations, Schiaparelli drew the most detailed maps of the Martian surface ever made at that time. There was just one problem. His maps included very straight, almost artificial-looking lines that he thought he saw when observing the Martian surface.
Now, he called them canali. And it was Italian, so he spoke Italian, of course. And canali in Italian best translates into English as channel. The problem was, canali is a lot like the English word canal. which is not a natural object. It's a constructed thing.
A wealthy Boston mathematician and astronomer named Percival Lowell became fascinated with Schiaparelli's canali. He believed that they were irrigation canals used by a dying Martian civilization for watering crops.
Lowell started with what he wanted to believe. He wanted to believe that there was intelligent life on Mars, and then went out to seek that evidence. And that's not a very good way to approach a scientific inquiry.
Lowell built an observatory in Flagstaff, Arizona, still in use today. From his observations, he drew his own maps of Mars, like this one on display at the Smithsonian National Air and Space Museum. But it was through his writings that his ideas became well known.
Instead of writing for other scientists, he wrote for the general public. And that means that what the public perceived about Mars in the early 1900s was dominated by Lowell's writings and much less affected by what the scientific community was saying.
Science fiction writers were also influenced by Lowell's ideas. Many books contain stories about Martian invaders leaving a dry, dying planet to take over the Earth.
Fast forward now a few decades to 1938. It's Halloween. Orson Welles has a radio troupe that does live radio broadcasts, sound effects, the whole bit. And they decide for Halloween to do a dramatic presentation, a dramatic reading, straight from War of the Worlds. And they treated it as a modern update with breaking news, cutting in.
Ladies and gentlemen, we interrupt our program of dance music to bring you a special bulletin from the Intercontinental Radio News.
Thousands of people tuning in mid-broadcast began to panic. They were convinced Earth was being invaded by Martians.
Gas tanks for the automobiles.
The public reaction revealed how widespread the belief in alien life on Mars had become in modern society. Through space exploration, we now know Martians, like the ones in our popular movies, cartoons, and books, don't exist. But at the time of War of the Worlds, the dawn of space exploration was right around the corner.
It wasn't until 1957 that the dream of space exploration became a reality with the launch of Sputnik by the Soviet Union. Though a primitive satellite, it marked the beginning of what's known as the space race, a competition between the Soviet Union and the United States for supremacy in space exploration. This quest for scientific discovery hasn't always been easy. Of 39 missions launched from Earth to Mars, only 19 have been successful. Some say there's a Mars curse.
It's very, very difficult to send a spacecraft to Mars and have it function properly. These are complicated spacecraft. They're operating in very difficult environments. And it's not like you can go down to the used Mars spacecraft store and buy something off the rack and just send it to Mars. We're using technology that's being developed for this purpose. It's very much, by definition, cutting-edge technology.
Using rockets similar to these, the United States has continually improved upon the technology to reach Mars, though the opportunity to launch, or launch window, is fairly brief. Every 2 years and 2 months, the planets align and are at their closest, which is about 35 million miles. This is called opposition. To reduce the amount of rocket fuel needed, this is an ideal and strategic launch window. For only 3 weeks, the planets are in opposition, but it takes 8 to 9 months to travel the distance. Timing is everything. Let me explain. If you slowly count 1 1,000, 2 1,000, 3 1,000, you actually just got about 20 miles closer to Mars. The distance from Earth to Mars actually changes that quickly. In November 1964, Mariner 4 launched, and after a long journey, in July 1965, succeeded in the first flyby of Mars. With an onboard camera and tape recorder, Mariner 4 captured the first images of another planet ever returned from deep space.
There was still a lot of holdover, especially in the mind of the public, from the days of Lowell and Schiaparelli. People expected to see canals. They expected to see vegetation. Mariner 4 returned just a few images. Less than 1% of the surface of the planet was seen. And it happened to catch some of the areas that we now call heavily cratered terrain. It looked a lot like the moon. And people were really disappointed, not just the scientists, the public. They had expected to see, hi, we're from Mars, putting signs up and things like that. And what they saw looked like the moon. Dead, lifeless, just like the moon.
Proving otherwise, just a few years later, and with some technological advances, Mariner 9 became the first spacecraft to orbit Mars and revealed a geologically advanced planet. Over 7,000 images vastly changed the way scientists thought about Mars and even included the discovery of volcanoes on the surface.
They're broad at the base and very low profile. They look like somebody laid a shield down on the ground. Call them shield volcanoes. And Olympus Mons, one of them, the one by itself, and the other three in a row, are the largest volcanoes anywhere that we've seen in the entire solar system.
Let's go to Jack, who's on standby with more.
Thanks, Alex. Landing on Mars became the next great challenge, and in 1975, Viking 1 and Viking 2 both succeeded. Each consisted of two parts, an orbiter and a lander. I'm standing in front of the actual proof test article that NASA used on Earth to test the spacecraft of the simulated Martian atmosphere. Just notice the stability of those legs. When released from the orbiter, the lander plunged toward the planet at 10,000 miles an hour. Immediately after touchdown, the cameras took the historic first close-up image of Mars and continued to transmit stunning images and data for almost 6.5 years. During this time, scientists used the Viking landers to conduct an array of experiments studying soil composition and atmospheric conditions. It's from these studies that scientists today know the exact proportion of gases that make up the Martian atmosphere. And it's with this data from Viking that we know little pieces of Mars have reached planet Earth as meteorites falling from the sky. Analysis of the gases contained in the meteorite match exactly the gases Viking measured in Mars's atmosphere, indicating these meteorites are actually rocks from Mars reaching our planet. Mars exploration has always been difficult, but each piece of data returned from the planet is a marvel.
Thanks, Jack. We're about to do a demo. All right, so I understand how we can identify how a meteorite is from Mars. So how does a piece of rock like this travel all the way from Mars to the Earth?
Well, Alex, that's a wonderful question. In fact, the answer is right before our eyes. If you look at any pictures from the surface of Mars, you'll notice that there are impact craters. So before us in this demonstration, we've created a Martian surface. What it is a paper box filled with white flour with cocoa powder sprinkled on top to make a nice Martian surface. Here I hold in my hand a piece of space rock. The space rock, when it flies through space, is known as a meteoroid. Right? When it impacts the surface of a planet, it becomes known as a meteorite. Okay, Alex, so now it's your turn to make an impact. We have a piece of space rock flying through space, being attracted to the planet by gravity, and it will land on the surface, forming a meteorite and hopefully a crater.
Okay. Whoa!
That sprayed a lot of flour everywhere.
Alex, you made a really good crater. The white material you see spread out over our planet here is called ejecta, and that's the material from underneath the impact. It spreads out in what we call an ejecta blanket. Scientists love to study that. It's like taking a scoop out of the surface of the planet, and we can study what those materials are made of. You made a really good impact based on the size of your space rock, now a meteorite because it's landed on the planet, and how fast it was going. So Matthew, it's your turn to make an even bigger impact.
All right. Awesome.
Wow, Matthew, that's a really great crater. Alex, if you go ahead and take out our meteorite, we can see that it's a much deeper crater. There's a rim around it. Ejecta, much larger, spread out over the surface. Now imagine this huge explosion that would have accompanied that material flung all over the surface of the planet and possibly even escaping the Martian gravity, beginning its journey to Earth.
Oh, so meteorites from Mars to Earth.
Exactly. That's how a simple rock can travel 140 million miles from the surface of Mars to the surface of the Earth.
That's amazing. Thank you so much for showing us this demo. Back to you, Kate.
Thanks, Alex. Let's take a minute for a Martian pop quiz. These are two images from two different planets, Earth and Mars. Both show impact craters. Can you figure out which picture is Mars? They both look pretty similar to me. We'll find out the answer in a minute. But first, let's learn how planetary scientists interpret images of the red planet.
I'm on the third floor of the Smithsonian National Air and Space Museum in the Center for Earth and Planetary Studies, also known as CEPS. Here, scientists research topics covering planetary science, terrestrial geophysics, and remote sensing of environmental change. CEPS is also home to a NASA-supported regional planetary image facility. Here, every image of the planets and moons in our solar system is cataloged and stored in these black books. CEPS has played a huge role in NASA missions to Mars by selecting landing sites and researching the features of Mars. Geologist Dr. Jim Zimbelman, along with geoscientist Dr. Patrick Russell, are hard at work interpreting images of Mars taken by a satellite that is currently orbiting high above the red planet.
So tell me what we're looking at today. Where did these images come from?
Well, these images came from a spacecraft orbiting Mars called the Mars Reconnaissance Orbiter. The camera is called HiRISE, High Resolution Imaging Science Experiment. And it's basically like a telescope attached to a digital camera.
That's incredible.
So we're going to start by looking at an image of a dune on Mars. A dune is made up of sand, and what Patrick is doing right now is zooming in, and we're seeing more and more detail.
So what does this tell us about conditions on the surface?
Most importantly, it tells us that Mars has enough wind to blow small particles around and make things like sand dunes. And the details are such that this is still going on today. That is an enormous surprise.
So can you show me another image?
What we'll look at next is an image of a lava flow. And I have an example of what the rocks in Hawaii look like. Well, that lava flow on Mars probably is very similar to this rock here.
So how do you know it's lava flow?
Well, for one thing, this particular image comes from a part of Mars that is very close to the large volcanoes. And the part that we're looking at now is the very edge of one of these flows of molten material.
I'm noticing on these images that there are so many craters. Why is that?
There are a lot of craters on here. Here you see some on the surface of this lava flow, like you pointed out. Basically, there's a lot of craters on Mars because it's been exposed to space for a long time. The longer a surface has been exposed to that, the more craters it accumulates. So we can use this number of craters, or density of craters on a surface, to tell how old one surface is relative to another.
So is there evidence of water on Mars?
Well, HiRISE is giving us examples of landforms that we are quite sure were formed at one point by flowing water. Patrick has an image of a place on Mars that has been very severely eroded, but one of the features that is left over from that erosion is this ridge. It is standing above the surrounding terrain. And if we found that here on the Earth, we would call it inverted topography. All that means is what used to be low has become high. How did that happen? We think that was the floor of a stream channel, and the rocks, the coarse material at the floor of the channel, protected the surface from all the erosion. These would be sedimentary rocks. And here is an example of a sedimentary rock, in this case a sandstone. It's made up of individual little sand grains, but in layers that were laid down in water. Then later, those grains got melded together to make it into a rock. And the strength of this rock is what protected the floor of the channel from erosion, whereas the things around it were softer and eroded away.
So looking at all of these images, what have we learned about Mars?
The goal of planetary geology in general is to understand not just one planet, but all planets. How are they similar? How are they different? HiRISE is helping us immensely in giving us details at a scale that human geologists are used to operating. HiRISE is an incredible new tool that is added to an arsenal of tools that people have been using for many years to try and better understand Mars as a planet, but how it relates to all the other planets.
Up next, the answer to the Martian pop quiz. Then, robot exploration. But first, did you know there's a face on Mars? Well, not really. This photo surprised scientists with a human-like face. Additional images and analysis soon revealed the trick of shadow and light. This 2-mile-long formation is actually just a Martian hill. The illusion appears when the sun is at just the right angle.
If you want to tell the HiRISE camera where to take its next picture of Mars, go to this website to find instructions. And who knows, soon scientists could be looking at images that you picked. All right, back to our Martian pop quiz now. Here are the two images that we showed you earlier, one from Earth and one from Mars. Which picture is Mars? If you answered B, then you're correct. The picture on the top was taken in Arizona at an impact crater that formed 50,000 years ago. The picture of Mars was taken by a robotic rover similar to this one right here behind me. Now, believe it or not, NASA is using robots to explore the surface of the red planet. Flight School's Matt Fetters is standing by to tell us more about these robotic pioneers. Matt?
That's right, Kate. I'm in front of a model of the Mars Pathfinder lander, which was the third successful lander on Mars. Originally designed to demonstrate new technologies, it showcased a new way to explore the planet and an innovative way to land on Mars. Notice the large deflated airbags. These were very important on July 4th, 1997, during the landing. Made out of an engineered material called Vectran, the airbags were strong enough to allow Pathfinder to bounce along the Martian surface for a safe landing. The Pathfinder was a stationary science lab, but within the shell sat the first robotic rover to successfully navigate the Martian surface. This rover was called Sojourner, which means traveler. Though it only traveled a total of 320 feet, it successfully analyzed rocks, soil, and weather conditions. The mobility of the rover allowed scientists back on Earth to remotely maneuver it to various places of scientific interest. Sojourner was a successful test in rover technology and blazed the trail for future Mars rovers. Flight School's Jack Tarbell is standing by with more about those missions.
Thanks, Matt. This is a model of one of the twin Mars exploration rovers named Spirit and Opportunity that NASA sent to the Red Planet in 2004. They're robot geologists designed for scientific discoveries. The primary goal of the mission was to search for and characterize a wide range of rocks and soils that might unlock the mystery of whether water, a key component to life, was ever on Mars.
Follow the water was an easy statement, short and concise, to summarize where we would want to go looking. Again, because biology, as we understand it, requires water in some form. That was what was driving NASA to make that the goal.
To reach this goal, tools on board the rover tested for evidence of water. A circular rock abrasion tool, or RAT, removed dust from the surface to expose fresh material for examination. On the rover's robotic arm, a microscopic imager provided extreme close-up views to help determine types of chemical elements present.
Opportunity was sent to a place that we knew from orbit had the chemical signature of hematite. What is hematite? It is a mineral that, at least here on Earth, normally forms in the presence of water. Doesn't have to, but by far the majority of cases that we are familiar with here on Earth, they form in the presence of water. So it was a chemical searchlight saying, come here to look for evidence of water.
Nicknames are given to the important rocks and features on Mars so scientists can refer to them easily as they study data. This more recent discovery shows a mineral vein nicknamed Homestake, made from gypsum, which is a mineral deposited by water. The vein indicates that long ago, water was flowing through a crack in the rocks.
Gypsum only occurs where you have water seeping through the rocks and standing on the surface for long periods of time, and it's actually transported by the water. So the discovery of this vein of gypsum is just an absolute slam dunk proof that water was there for a long period of time.
After 7 years and traveling over 4 miles on the Martian surface, Spirit became trapped in sand, and eventually communications with Earth went silent, thus ending the mission. As of this broadcast, the Opportunity rover is still functioning. Soon to join the twin rovers is a new and larger rover named Curiosity. It has more tools, technology, and capability than ever before.
We'll have more on the new rover and how it is seeking signs of life in a minute. But first, did you know that there are avalanches on Mars? Traveling down a steep slope that is more than 2,300 feet tall, this dramatic snow movement is thought to be caused by the warming atmosphere in the springtime on Mars. Scientists are tracking this area on the North Pole to view similar avalanches. Now, with all that ice and snow, do you think you could build a snowman on Mars?
I'm here with Michelle Selvins, who is a planetary geophysicist and an expert when it comes to the Mars North Pole. She's here to demonstrate the Martian atmosphere using some unusual elements. So Michelle, we were wondering, can you make a snowman on Mars?
Well, there is snow on Mars, and there's even 2 polar caps that are ice like we have on Earth. However, there's a couple things that are different on Mars. One is the atmospheric pressure. The pressure is so low that water ice behaves a lot like dry ice on Earth. The other thing that's really different is the temperature. All right, so let's put these spoons of water on the dry ice and the water ice and see what happens.
Okay.
So the spoon you're holding is warm right now, and the dry ice is really cold. So the temperature difference is what's making that happen.
Oh wow, that's. And it's stopped.
Well, we've seen how different the temperatures are of these two. So let's put these two under this heat lamp over here, and we'll come back and look at what the difference is between how they behave over time, the dry ice and the water ice.
So if there are polar ice caps on Mars, doesn't that also mean that there's water?
There is a lot of ice, but because of the pressure and temperature differences between the Earth and Mars, all of that ice actually goes directly from ice into gas. It doesn't go into the liquid phase at all. So in order to sort of show how that happens, we have a lot more water here, and I was wondering if you just pour it on top of the dry ice for me.
Like all of it?
Yeah.
Oh. Oh.
So
that is cool.
We just figured out that the water is a lot warmer than the dry ice, right? So what does it look like it's doing to the
It
dry
looks
ice?
like it's boiling. Whoa.
So what's happening is that the dry ice is solid and it's going directly into a gas, which is what's creating the white that's inside all of those bubbles. That's all filled with the CO2 gas. And that process is called sublimation, when you go directly from a solid to a gas. And on Mars, this would be happening with water ice too. At the poles, you just have the ice that's built up there going directly into the atmosphere and back without turning into liquid at all. The opposite of sublimation is when you're depositing, so you have deposition from gas into solid directly.
So how did the polar ice caps get there? Is there water underneath?
Well, we've actually looked through the polar ice caps with radar at Mars. There's 2 different instruments that can look all the way through the ice, and there's 2 miles worth of ice stacked on top of each other. There isn't actually liquid water underneath. We can see the rock underneath. So it looks like it wasn't deposited with any kind of melted layer, but simply over time, and probably over something like 2 billion years, in the North Pole at least, you just built ice slowly up on top through deposition by taking it directly out of the atmosphere into a solid. Let's look at the plates we put aside before. So here's the water ice, and here's the dry ice. And what do you notice now about how they look?
Well, the ice is melted. It's almost gone, and this, I don't see any difference.
Yeah, so you can actually barely tell that anything is going on here, and certainly there's no liquid. So instead of melting, all of that, what has actually disappeared has gone straight from solid into that vapor that you can kind of see coming off. And this is exactly how water ice would behave on Mars. This is how the polar caps behave.
So even though it snows on Mars, it would be hard to build a Martian snowman without the slushy melted snow to hold it together. It would be more like stacking ice cubes.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, 0, and liftoff of the Atlas V with Curiosity, seeking clues to the planetary puzzle about life on Mars.
This is the moment that planetary scientists, engineers, and NASA officials have waited for. This rocket is carrying the new, highly advanced Mars Science Laboratory, or MSL, with a rover named Curiosity.
I've been working on Curiosity for about 7 years, and at times with over 1,000 people. And really the challenge has been to get everybody's ideas, everybody's desires of what they want this rover to do and how it works and what science is going to do to all come together to where it is today. We've gone from writing things on chalkboards and napkins to CAD drawings and blueprints, and then building it and testing it, and now it exists and it's there on the rocket.
The spacecraft carrying Curiosity has a long journey ahead, scheduled for an August 5th, 2012 arrival. Curiosity will have a challenging but well-planned landing.
The first thing we do when we reach the Martian atmosphere at about 12,000 miles an hour is we use the Martian atmosphere itself to help slow us down. We use aerodynamics and drag, the same kind of drag that makes it hard for a car to go fast on the highway, slows us down when we hit the atmosphere. And that drag is so energetic that it creates a lot of friction that actually heats up the spacecraft. It would actually melt the spacecraft. So we protect the spacecraft in a cocoon or an aeroshell that helps insulate it from that heat of the friction.
A supersonic parachute deploys to further slow down the spacecraft. Then the heat shield separates as the landing radar looks for the Martian surface. About 1 mile above the planet, the spacecraft separates from the back shell as landing engines fire up to slow the descent even more. But the really cool stuff happens when the sky crane lowers the rover to the surface.
The sky crane looks more than complicated, it looks crazy. And so it's only through this cable system that we can really do a true soft landing with the rover on the surface. And since the rover's wheels are designed to interact with the Martian surface, it conforms and is stable under a variety of terrains that a legged lander would not be able to land on. So we can take our sky crane and land in places we would never have been able to land before.
The landing site, Gale Crater. The target? Clay minerals and sulfates. Both would indicate water was previously at this location.
And this is a fascinating place. It's a huge crater. It's like 100 miles across, and it has this mound in the middle of it that's 3 miles high. With cameras from orbit, we can see layers. We can see ridges. And if you can imagine taking a book and putting it face down and looking on the side of the book, you can see layers, you can see the pages. And for geology, those pages, those layers, are pages of history in Mars. And so the big advantage of going to Gale Crater is we see all those layers. We can take the rover there, and as we drive up the mound, we can go across these layers and read each page of Martian history as it went from the warm and wet climate it was to the cold and dry climate that we see today.
Designed as an all-terrain vehicle, Curiosity has big wheels and a tall ground clearance. It's a self-contained roving science laboratory with 10 scientific instruments to analyze the surface. In fact, from 23 feet away, a rock-zapping laser and telescope can vaporize the rock to identify its chemical elements.
To improve your understanding, even before you have to go up to a rock, now you can zot them with the laser, get their elemental composition, and you go, oh, look, there's a carbonate over there. We've been looking for one this whole time, so this is great, our first carbonates. And then you can roll over and then do your measure the rock as you want, maybe even drill into it and feed it to your analytical lab.
We have a big jackhammer drill at the end of our robotic arm. Places a big jackhammer onto a rock and then pounds away at that rock for several minutes, creates powder. And then we collect that powder, and on the end of the arm, we can move that powder around through some sieves, and then we deliver that powder into the rover body itself, where these 2 big laboratories are. And each one of those laboratories analyzes the powder.
This will be the first time a rover is able to sample Mars. Scientists are seeking signs of life.
We don't anticipate seeing green Martians. Our guess is that if we were to see any type of life in a future mission, it would be something like a microbe, something microscopic. And part of why we think that is here on Earth, when we have gone to unusual places, whether it's deep at the bottom of the ocean, down to Antarctica, we look at these places and they seem as if they would be unable to support life because they seem very extreme to us. They're too hot, they're too cold. Then when we think, well, we couldn't live there, what could possibly live there? But in fact, scientists always seem to find life in the most unusual and unexpected places. I think microbes can do just about anything. And I think everywhere we look, we find them. And so it would not surprise me one bit if we were to go to Mars or even further out in our solar system and find something like a microbial, microscopic life form there as well. I just have tremendous faith in their ability to to adapt and figure out how to make a living out of almost anything that's around them, because they do it here on Earth.
The discovery of methane gas in the Martian atmosphere is also challenging scientists to continue seeking life. Methane is a natural gas that can be released by living organisms or by simple geological processes, such as gas from underground ancient volcano activity.
One of the important things of the recent report of methane in the atmosphere of Mars means that Mars is dynamic. It's the surface and subsurface is communicating with the atmosphere. And what that means is the planet, at least geologically, is more active than we thought. And it also could be a sign of biological activity. And so we're very interested in that. And so the subsurface underground water may be, let's say, the last refuge for Martian life to be.
Both the source of the methane in the atmosphere and the location of living microbes is a mystery. Robotic investigation of the planet helps further our knowledge. But eventually, we hope to put life on Mars in the form of human astronauts to further explore the planet. In fact, that astronaut could be even watching this program right now.
Astronauts usually, when they're picked to fly on space missions, they're usually mid to late 30s. And so if we're really expecting this to happen 20, 25 years from now, I mean, you guys do the math. I mean, it's like, that means these first explorers to the surface of Mars are somewhere in our schools right now. There was one day when Neil Armstrong was in kindergarten, and who would have ever thought that this young little boy would grow up to be the first person to step foot on the moon?
It's one small step for man, one giant leap for mankind.
Going to Mars is hard. It's hard for us. It was hard when we took a little backpack-sized rover. It got harder when we took a coffee table-sized rover. But it gets really, really hard when you start talking about taking a house, which is what you kind of need to do if you want to take people. That kind of challenge, I think, makes us better.
To overcome the challenges, an ongoing commitment to scientific discoveries is necessary.
So when are we going to send humans to Mars? Basically when we really want to, because right now, although there are some technological hurdles, they are more of big engineering challenges than having to invent something new. So we don't need some technology miracle to make it happen for us to go to Mars. It's just more of whether or not we really want to spend the resources to send humans.
Then in the human spirit, I think we all have this exploration and discovery kind of woven into our genes, you know, where we just want to know what's just over the horizon, or just on the other side of that river, or just on the other side of that mountain, whatever it might be, you know. So we're a curious species, and I think to stop exploring would be to stop being human. I mean, it's just part of who we are, and who knows what we'll find out, you know, through the process.
By now, you might be interested in becoming a Mars scientist, engineer, or the first astronaut to the Red Planet. Continue with your studies and you might work for NASA one day. From all of us at the Fairfax Network, thanks for watching. I'm Kate Sullivan.